Alright, today we'll talk about the decorator pattern. So sometimes we want to add responsibilities to individual objects and not have these responsibilities belong to an entire class. So let's imagine we were implementing some kind of text box, and in the text box class we have this ability to draw. Okay, now we might want the ability to have scroll bars, both horizontal and vertical, along with maybe a border of some kind on some, but not all, of the text boxes. Okay, so there are three separate features we'd like to add to a text box: horizontal scroll, vertical scroll, and this ability to have a border. You might be tempted to use inheritance, but since all three additional features are really mix and match, it's hard to specify an exact hierarchy. Right? You could say, well, we will have this hierarchy where we have text box and then horizontal scroll and horizontal and vertical scroll and horizontal and vertical and bordered text box. Okay, but then you might say, well, what if I only want a horizontal text box with a border? Well, then I really should create a hierarchy that has every possible scenario. So we have the text box and we have the horizontal, vertical, and border text boxes by themselves. And then we have kind of every single combination here. Since the order, whether it's horizontal or vertical or border, doesn't matter. Instead of having 8 total, we have basically 6 subclasses. Okay, so you have to build a pretty large hierarchy to account for all of these classes. And in general, we should try and keep our inheritance hierarchies as small and simple as we can. Adding just a few features to a class can cause us to create a very complex hierarchy. A more flexible approach is to enclose one object in another that adds some functionality. And the enclosing object is called a decorator. Okay, so the intent of the decorator is to attach additional responsibilities to an object dynamically. And these responsibilities can be added and removed at runtime while the program is running, perhaps in response to the size of the window changing. Right? So the scroll bars in particular are kind of sensitive to the size of the window. Decorators provide a flexible alternative to subclassing for extending a class. Okay, the decorator conforms to the interface of the component it decorates so that its presence is transparent to the client. The decorator forwards requests to the component and may introduce additional behavior either before or after the component's core behavior. Now the transparency allows one to nest decorators recursively, allowing basically an unlimited number of additional responsibilities to be added to individual objects of a class. Okay, so let's look at the system without decorators. Okay, so we have this client who's going to send a message to draw to a text box. Okay, and again, the goal is to add this these additional features, some scroll bars and maybe a border. One thing we're going to do is we're going to create this interface, which I call visual component, which really describes what the text box is going to do. So remember, we had one method called draw, so we're going to pull that up into the visual component interface and make sure the text box implements that interface. And the goal here is to have that text box object in the middle, but then wrap it around with another object. This is the border decorator, and wrap that whole object inside another one called the horizontal scroll decorator. Okay, all of these are going to implement that visual component interface, so they all have this ability to draw. Now the client doesn't know or care what it's talking to. It just knows that it has a reference to something that it can call draw on, and when it does, it's going to call draw on the decorator. The decorator is going to do a little bit of extra work, in this case build a horizontal scroll bar, and then pass the message on, the draw message on to the next nested object, which is the border decorator. And the border decorator is going to do a little bit of work, draw a border, and then send the draw message onto the actual text box, which will draw a normal text box. Okay, so that's the idea of the decorator. We wrap objects in one or more of these decorators. Okay, so let's take a look at how this is going to work. Again, we start with the client. The client has a reference to a visual component. Remember, all three of these are visual components. We'll see the class diagram in a second, but they either implement the interface or extend a class that is a visual component. So the client can send the draw message to the horizontal scroll, and here maybe the horizontal scroll bar will draw the horizontal scroll bar first, and then send the draw message to the border. Okay, the border decorator will draw a border and send the draw message onto the text box. And eventually the text box, remember that was the original component, it's going to do its thing, and the flow of control is going to return back through here to the client. And all the client knows is it called draw, and something happened. Okay, so like I said, the client sent the draw to a visual component, and each visual component did a little bit of work and passed the message on to the next innermost object. The additional responsibilities are in the horizontal scroll and border classes, not in the text box class. So we decided not to touch the text box class. And we might do that for several reasons. Either we might not actually have access to the source code for the text box, or there may be other teams that require that text box not change. The additional behavior can happen either before or after the core functionality. In this case, I drew it as the additional behavior happening before. But remember, there is a flow of control that returns back through this series of calls, and we could do additional behavior after draw was called. Okay, let's look at the structure of the decorator. So we start with a component, which is an interface, and it has some operation. Okay, then we have the concrete component. This is the actual object that we're going to wrap. And then we have this class called a decorator. The decorator implements this component interface, but also has a reference to a component, and we call this data member the decorated component. Okay, and when somebody calls the operation method on a decorator, what it's going to do is use its reference to the decorated component, and it's going to forward the call on to the operation. Okay, then we have some concrete decorators where, again, in the operation method, the overloaded operation method, we're going to do some additional work either before or after. And then since this class inherits from the decorator, we'll ask the parent to call the operation on the innermost, or the next inner object. Okay, so let's put this in terms of our problem. Okay, so we have the visual component interface, which has a draw method. So visual component is equivalent to our component. And then we have a concrete component, that's ultimately the object that's going to do the core functionality, the core bit of work. So in our case, that's the text box. And then we have a decorator, which its main purpose in life is to maintain this reference to another visual component. So we call that the decorated component. And then we have the concrete decorators, of which there's a vertical scroll, horizontal scroll, and a border. Okay, and we'll get to the code here in a second. First, let's talk about the participants. The component defines the interface for objects that will be decorated. And remember, you can put decorators around decorators, and you can put those around decorators. There's a concrete component that defines the object where the responsibilities can be attached. We have the decorator maintains a reference to a component to call either before or after the additional work is complete. And the decorator implements the component interface. And finally, the concrete decorator adds some responsibility to a component. Okay, so let's look at the code, and then we'll talk about the consequences. Okay, so we start out with this interface called Visual Component, and we just have the single method draw. And then we have this class called TextBox, which implements Visual Component. And to simulate it here, I'm just going to do some prints. So the TextBox draw just says TextBox drawing. Okay. Now the visual decorator, remember this is the object that maintains a reference to a visual component. We have that reference right here. It's called the decorated component. And this class does not do much other than just kind of store a reference to the decorated component, and then when somebody calls draw on it, it asks that object to do the drawing. Okay, so this is a reference to a visual component that can be drawn. We pass in a visual component. Okay, that might be a concrete component, might be another decorator. And then when somebody calls draw, we ask the decorated object to do its thing by calling draw. Now let's start to look at the concrete decorators. We'll start with the horizontal component. We'll see they're all pretty much the same. Horizontal component extends visual decorator. Okay, so this is inheritance, not implementing some interface. So the horizontal scroll, it absorbs everything that the visual decorator is, including that reference to the decorated component. Okay, so we always pass in the thing that is getting wrapped up. It's always a visual component. And we could just call the base class constructor to store that. And then when somebody asks a horizontal component to draw, here it's going to ask the decorated component to do its thing, and then it's going to do the additional work. Okay, so maybe drawing the horizontal scroll bars would happen here. Again, the order of these two can be reversed. And I think in the pictures I decided to kind of say that we're going to do the horizontal scroll bar first and then ask the decorated component to do its work. Here, just to show you can do either one. In this case, the very first thing that should happen is the plain old text box should show itself being drawn. Okay, the vertical component. This is what I'm calling the scroll bars. This again also extends a visual decorator, passes in a visual component to wrap itself around, and then when you ask it to draw, it's going to ask the decorated component to draw and then add a little additional work. And the border component, again, very similar. When you ask it to draw, it's going to have the decorated component do its work and then add a little bit of additional code. Okay, so let's see how this might work in a driver. Okay, this hopefully will put all the pieces together. So we start with our text box, which we know is a visual component. And then here we might be able to decide, well, is the height of the screen less than, let's say, 200 pixels? And if so, we would take that plain old text box and wrap it inside a vertical component. So that's the vertical scroll bar now is kind of wrapped around the plain old text box. And if the window's width is less than 200, well, maybe we'd wrap that object. So notice, when we created the vertical scroll bar, we stored that right back into a vertical component reference, TB. So based on whether this if is true or not, TB is either going to point to a plain old text box or a vertical component that wraps around the text box. Okay, so if the width is also less than 200, we could take that object and wrap it in a horizontal component. And again, TB, since they're all visual components, TB can point to any one of these things. And then finally, we wrap it in a border component just to show you it can be done. And then when we ask TB to draw itself, it's basically going to go through that collection of decorators and eventually get to the actual text box. Okay, so let me just run it really quickly. Okay, so we see the text box drawing happen first, and then we had the vertical, horizontal, and border functionality in the decorators take over. Okay, so in the driver we called draw, and we got the kind of text box stuff happen first, and then the vertical scroll bar got drawn, and then the horizontal scroll bar got drawn, and then the border got drawn. So again, because I chose to call draw first, we did in the output here we should see we had the text box drawing first, followed by vertical, horizontal, and border. Okay, that's on the return back from calling draw. We hit vertical, then horizontal, then border, and by the time we got return from the draw method, okay, all of that additional behavior got injected into the system. Okay, let's quickly talk about the consequences here. With the decorator pattern, we have more flexible, it's more flexible than static inheritance, and you can add and remove behavior at runtime. So this is definitely different than if you used plain old inheritance. That's a compile time thing. Now with these decorators, we can choose to add and remove them. This pattern avoids feature-rich classes at the top of the hierarchy, where maybe not all the subclasses may want or need all of those features. We really can plug in and out only the things we need. And one final consequence is there are a lot of little objects, and this can make your system a little bit hard to comprehend. But you know, that's the price we pay for this decorator pattern.